Okay, class. I wanted to go ahead and go over this problem that I went over in class on Monday to give you an opportunity to hit pause and to really think about what we did and to attempt it yourself and then hit pause and maybe take a peek if you get stuck. So this problem number 55 on page 283 says an investor has $60,000 to invest in a CD and a mutual fund. The CD yields 5%, that's 0.05, and the mutual fund yields an average of 9%, 0.09. The mutual fund requires a minimum investment of $10,000, and the investor requires that at least twice as much should be invested in CDs as in the mutual fund. How much should be invested in CDs and how much in the mutual fund to maximize return? What is the maximum return? So if you can do a table, you should. This one is not super table friendly because it deals with percentages and then it compares the two. If you have equations that compare the two variables, it's a little more difficult to put into a table form. So in this case, you just write down all the comparisons and all the possibilities and then graph them all. So let's look at it. Investor has $60,000 to invest in a CD and a mutual fund. So right away, I'm looking at CDs and mutual funds, and I'm looking at, and then I go to the question, how much in the mutual fund and the CD to maximize the return. So how much in the mutual fund, how much in the CD, that's your X and Y variables. So I'm going to let X, and this triple equals, X equals amount invested in CD, CDs, and Y. And when you label variables like this, when you give a variable a definition, you use triple equals. Y is amount invested in mutual fund. I'll use MF for mutual fund. It'd be nice if I could spell the word in. I was thinking MF in mutual funds. All right, and notice you have $60,000 to invest, so X plus Y should be less than or equal to 60,000. You could probably hear my daughter's bird in the background. I apologize. X plus Y less than or equal to 60,000. The CD yields 5%. The mutual fund yields an average of 9%. So your return on your investment, you're actually trying to maximize your return. We'll call that R. And that is 0.05% or 5%, 0.05 of the amount you invest in CDs plus 9% of the amount you invest in mutual funds, Y. And this is annual return, 5% annual return in the CDs, 9% annual return on the mutual fund. So X plus Y has to be less than or equal to 60,000 because that's all we have to play with here is 60,000. The mutual fund requires a minimum investment of $10,000. So Y is going to be greater than or equal to 10,000. Which means X has to be less than or equal to 50,000. Because if I have to invest 10,000 in Y, then the most I can invest in X is 50,000. So those are good equations to graph. And here's a little tricky. The investor requires that at least twice as much should be invested in CDs as in the mutual fund. If I invest twice as much in X as I do in Y, for example, let's say I invest $10 in CDs, and that's at least twice as much. So let's say I do $10 in CDs. That means the amount I invest in mutual funds is going to be 5. So 10 is twice 5. So to set them equal to each other, I've got to multiply the 5 by the 2. By 2. And then if I subtract them, I get 0. And the reason I want you to think like that, a lot of people can't get this relationship. This is the hardest equation in this question. So the relationship is twice X, twice the amount I invest in CDs. I'm sorry. Here I'm making it more difficult too. The amount I invest in CDs, X, is twice as much as I invest in mutual funds. So if I multiply the amount I invest in mutual funds by 2 and subtract them, it should be equal to 0. All right. Now X can be more than twice, so that means X minus 2Y should be greater than or equal to 0. All right. And again, for example, let's say I invest $10 in CDs and $5 in mutual funds, then 10 minus 2 times 5 is equal to 0. If I invest $10 in CDs and only $3 in mutual funds, then X is more than twice, and that's fine. And then 10 minus 2 times 3, 10 minus 6 is greater than 0. So this is a good equation. This is the one you really have to think about. Hit pause, get it into your mind that this is a good equation. And let's see, the investor requires at least how much, and that's it. So we are maximizing this return, 0.05x plus 0.09y, subject to these constraints. X plus y less than or equal to 60,000. Y greater than or equal to 10,000. X less than or equal to 50,000. X minus 2y greater than or equal to 0. And then we have our implied inequalities of positivity, X greater than or equal to 0, Y greater than or equal to 0. We're going to invest something. You can't invest a negative amount. Okay, so we just graph these 1, 2, 3, 4, 5, 6 inequalities, and then we're going to check the corners or the feasibility region to see which one of the corners, which one of the kinks make this return the largest. So let's graph this real quick. I'm going to hit pause and draw the graph just to save some time. So here I have an XY axis, and each one of my tick marks is in 10,000s. So 10, 20, 30, 40, all the way up to 100,000 on the X and the Y. So let's get some T's here. Here's the X and the Y coordinates. X plus Y less than or equal to 60,000. Again, you're graphing as if they're equal. All of them are going to be solid because I have less than or equal to, not just less thans or greater thans. X plus Y, if I put a 0 in for X, I get a 60,000 for Y. And if I put a 60,000 in for X, I get a 0 for Y. And then Y greater than or equal to 10,000, that's just a horizontal line at 10,000. X less than or equal to 50,000, that's a vertical line at 50,000, so we can draw those two. X minus 2Y greater than or equal to 0. And since I'm 10,000s and 20,000s, let's put a 20,000 in for X. That means Y is 10,000. 20,000 minus 20,000 is 0, so Y is 10,000. And put a 0 in for both. This thing does go through the origin, so 0, 0 is a good statement as well. And then X greater than or equal to 0 is anything to the right of the origin, and Y greater than or equal to 0 is anything above the X-axis. So I'm in the first quadrant. So easy to graph here. I'm going to hit pause and graph the 0, 60,000, 60,000, 0, and the 20,000, 10,000, 0, 0, as well as the Y greater than or equal to 10,000, X less than or equal to 50,000. So just a second here. So here's the 0, 60,000 point and 60,000, 0, and the line that connects those two. And I'm going to draw the Y greater than or equal to 10,000, X less than or equal to 50,000. So here I put the over 0 up 10,000 ordered pair, and the Y greater than or equal to 10,000. And greater than or equal to 10,000 will be above it. X less than or equal to 50,000 is this vertical line, and it goes through the point 50,000, 0. And less than or equal to 50,000 is going to be to the left of it. And the X plus Y less than or equal to 60,000, 0, 0 satisfies it, so I'm going to be below it. So far I'm in this little triangular region here. So I have to figure that out. And then finally, the x greater than or equal to 0 just puts me in the first quadrant. Y greater than or equal to 0 puts me in the first quadrant. X minus 2y greater than or equal to 0. I have to graph this 20,000, 10,000. So over 20,000 and up 10,000. I'm right here. And 0, 0 right here. So let me draw a line through that real quick. And again, this is, let me do this in red like the other ones. This is over 20,000, up 10,000. And this one down here is 0, 0. Let me draw a line through those. There we go. And that is the line x minus 2y greater than or equal to 0. And I can't pick 0, 0 this time. I have to pick a value above or below and see if it's true. So, and let's see. I want to make sure this goes exactly through that other point. Let me click on this real quick. Looks like I have it a little too high. Let me slant it down. There we go. So good to go. All right. So we can pick over 0 and up 20,000. If I put a 0 and 20,000 in, it fails. If I put 20,000 0 in, which is below the line, 20,000 0 wins, so it's below. So our feasibility region is this. Let me just highlight this a little bit better. This triangle. So we've got to find these. We already have one of them, the 20,000, 10,000. This one right here is the x plus y equal to 60,000. Let me get a better marker here. X plus y equal to 60,000. We use equality to solve for these intersections. And the x minus 2y equals 0. So we can use Cramer's method. I'll leave it up to you, but you're going to get the scale is pretty good. That is 10, 20, 30, 40,000 and 20,000. Over 40,000 and up 20,000. That's this ordered pair right here. Over 40,000 and up 20,000. Okay, and then this order pair you can see is 50,000, 10,000. Over 50,000, up 10,000. And the final ordered pair is the 20,000, 10,000. You just have to check those 3 points in this return function. So I'll set those up and then we'll look at it. And that's it. The biggest one wins. Oh, by the way, I put it on Desmos as well so you can see it a little bit better. This is your feasibility region, the same triangle we had before. So we're testing those 3 points. So let me set up the test and we'll look at the results. So here's my return equation tested with all 3 ordered pairs, the 20,000, 10,000, the 40,000, 20,000, and the 50,000, 10,000. And the 40,000, 20,000 wins. You should invest $40,000 in CDs and $20,000 in the mutual fund. You'll get your largest return of $3,800. So I hope this video helps. I'll give you some homework to do for Wednesday's class. We'll do one more of these, number 56. I'll make a video for it as well. And then I need you to read the book and look at homework for the simplex method. All right. See you on Wednesday.